Okay, so in Chapter 9, we are combining information from Chapter 7 about ionic compounds with some more information from Chapter 8 about molecular compounds, and we're going to learn how to name and write formulas for all compounds. So we're going to start with ionic compounds, specifically binary ones, where a binary compound is composed of two elements. So if you're looking at the symbols, there's only two elements in the whole formula, okay? And binary compounds can be ionic or molecular, but we're going to start with ionic. So if you can name it, you can also write the formula. So we need to have some extra information besides what we've already written down on our periodic table about charges. That whole middle section, the transition metals section, most of those have more than one option for their charge. And because of that, we have to signify what the charge is somehow. And so to do that, we use a Roman numeral. So whatever the charge is, that will be the Roman numeral on the name. So like copper can be a +1 or a +2. So we would say copper 1 if it's a +1, or copper 2 if it's a +2. And all the way down the line, iron can be 2 or 3, lead can be 2 or 4, tin can be 2 or 4, and nickel can be 2 and 3, I'm pretty sure, but we only use nickel 2, so that's why I threw it on there. So you're just going to have to kind of remember this list, because if we're looking at our periodic table to write charges and formulas, and you see it's in the center, then you're going to just have to make that connection, like, oh, I need to go look at the notes to see what it might be, and go from there. But always remember, the Roman numeral tells us the charge, not how many there are. There are two in the transition metal group that do not need Roman numerals, and that is silver and zinc. Silver always has a +1, and zinc always has a +2. So because they don't change, just like the column 8, 1A through 7A, those never change, then we don't have to have Roman numerals. And even though it says silver ion and zinc ion in a name, like if we had AgCl, you would just call it silver chloride. You would not need to put the word ion anymore. So if you don't want to write those down, that's okay. Alright, so to name our compounds, we're going to start with a cation and an anion. Remember, cations are positive, and cations always come first with naming and formula writing. And so we're going to just name them. Just like in Chapter 7, if it was a cation, we left the name the same as the periodic table. If it was the anion, so if it's from the non-metal section, it's going to change to IDE ending. Okay? So for the first example, we have Cu + 2 and S - 2. Well, Cu stands for copper, and S stands for sulfur, but it's second, and it's an anion, so we're going to call it sulfide instead. Okay? We're missing one more thing on this one, though, because copper was just on our list of Roman numeral elements. So we have to put the Roman numeral of what the charge is, and it has a +2 charge, so we're going to put a Roman numeral of 2. So copper 2 sulfide will be the name of the compound formed from that. The next one we have Na+1 and Cl - 1. So Na is called sodium, and sodium is not a Roman numeral element because it's from 1A. So that means that every time it's going to be a +1 charge, so no Roman numeral needed. And Cl stands for chlorine, but it's second, and it's the anion, so we're going to call it chloride. Sodium chloride. And the last one, we have Al + 3 and Br - 1. So Al + 3 stands for aluminum, and Br - 1 stands for bromine, but we're going to change it to bromide. So naming's not that bad. Now, we're going to do the formula writing. So we're going to go and think about it the opposite way. So to write the formula, we want the charge to balance to 0. Okay, if it doesn't, we would need to add additional ions until it does. Tomorrow, or on the next video, before we move on, I'll teach you a shortcut way of doing this, and it does make life a little easier for most people. If you don't understand it, that's okay. So what we have to do first is out of the way from our answer, we are going to write down what the ion and its charge is, so then we can look at them and see if they balance to 0. And if they don't, we need to add some more. So The first one we have is sodium fluoride. Sodium is Na. We just saw it on the last slide. And sodium is column 1A, so that has a charge of +1. Remember, if you just put a plus sign, that implies +1. And fluoride would be like fluorine from the periodic table, so that's just an F. And its charge, since it's in 7A, is a -1. So, to know if we can write this formula correctly, we look at the charges. Right here. Okay? And if those charges add up to 0, then we're all good. If they don't, then we have to do a little bit more work. But in this case, we have a +1 with a -1, so those do cancel out. So then our formula for sodium fluoride, we just get rid of those charges, and it will be NaF. So when you write a formula, no charges should be left there. Okay? Next, we have magnesium chloride. Magnesium is Mg. It's in 2A, so it has a +2 charge. Chloride stands for chlorine, and that has a -1 charge. So now, when we are looking at our charges, they do not add up to 0 this time. So we have to add additional ions until it does. So we can only add what we already got. So we can either give some more Mg+2s, or we can give more Cl-1s. In this case, we're going to add another Cl-1, because then, with that, we have an overall -2 to balance out the +2. So we're all good. And so to write the formula, we have 1 Mg, so Mg just stays normal. And then we have 2 chlorines, so we're going to put Cl, and then as a little number underneath, as a subscript, we'll put a 2. So MgCl2 is the formula for magnesium chloride. Last one is aluminum oxide. Aluminum is Al+3, because it's in 3A. Oxygen for oxide, and that has a -2 charge from 6A. So those charges do not add up to 0. So we need to add ions until it does. So this one, when they don't just evenly work out nicely, we have to make it a common multiple. So a common multiple of 3 and 2 would be 6. So that means we have to have an overall +6 and an overall -6 charge. So to make a +6 charge, I have to add another aluminum. And to make a -6, I have to add 2 more oxygens. So now we, looking at the charges, have a +6 and a -6. So then our formula is going to be Al2O3. Alright, so those are how we write binary compounds, so just from the periodic table stuff. But now we have to throw in those wonderful polyatomic ions that we're getting quizzed over, and how to write those as well. So it's still going to add up to 0, like we've been doing to write the formula. The name of it, if it's a polyatomic ion, whatever the name is from that half sheet of paper, your study list, that's going to be the name. You don't have to change anything about it, okay? So we're going to write the name first, and then we'll write the formula. So the first one we have Na+1 and NO3-1. So Na+1 is called sodium. We should all know that. And NO3-1, looking at your half sheet of paper, is called nitrate. So the name of that will be sodium nitrate. Okay. Now, for the formula, we're still balancing the charges to 0. So we have a +1 and a -1, so those just go away. And our formula will be NaNO3 for sodium nitrate. Next, I'm going to pull the teacher card and make it a little bit more difficult, because copper is a Roman numeral element, so it can be a +1 or a +2. And to make things more difficult, we're going to make it a +1 instead. So make sure that it says Cu+1 in your notes. Okay, so I just kind of told you it's a Roman numeral, so the name, we're going to have copper, and it's the charge for the Roman numeral, so it's going to be copper-1, and then SO4-2 is called sulfate. So copper-1 sulfate is the name of the formula. Now, or the name of the compound. Now to write the formula, we need to balance these charges to 0, and I was mean and made it not balanced. So we're going to have to add another Cu+1, in order to get that to balance. So then our formula will be Cu2SO4. Notice how the polyatomic ion stays the same and stays together. The halves look identical to your sheet, except that you should drop the charge, because the charge should balance out. Alright, the last one shows us that we can add two polyatomic ions together, because we do have one positive polyatomic ion, and that one is ammonium. And then OH minus 1 is called hydroxide. Okay. And then the charges do balance. So some people like to just be like, oh, I have hydrogens in both, so let's combine them. And this is not the right answer. Do not write this down. But they would go like NH5O. Well, looking at that later, you're going to have no idea what that is. So don't do that. Don't write that down. Okay? Instead, keep the polyatomic ion group together like how it is in your study sheet. So we're going to keep it NH4 to show that it's ammonium, and then OH to show that it's hydroxide. Okay? So we are now going to practice this for many, many days so that you are a pro at naming and writing formulas for ionic compounds.